This program is brought to you by Stanford University. Please visit us at stanford.edu.
This presentation is delivered by the Stanford Center for Professional Development, providing graduate-level education to working professionals, online, on campus, and on-site. For more information, please visit study.stanford.edu.
Welcome to the penultimate session on the fall Stanford HCI seminar. We're really lucky to have Ted Selker, not just today for the seminar, but also for the year as Ted's visiting us in the Bay Area for his sabbatical year. And Ted's done an enormous amount of work over the last a whole bunch of years now in HCI, and everything from Ted was one of the main inventors of the track point that many of you use every day on your laptops. Ted was one of the leaders at the IBM user group that started a lot of the HCI research there. For the past 8 years, Ted's been at the Media Lab, where he directed possibly the research project with the best name of all time. It was the Counterintelligence Project, but on kitchens that were smart. Yeah. And Ted's also done work on a number of other things, including voting technology, which I think is a really timely and important issue. And today, Ted's going to talk with us about his work on context-aware computing. So welcome, Ted.
Hi, so it's fun to be back here. I enjoyed being part of this forum from the beginning. I actually ran a seminar series from 1980 to 84 at Stanford Computer Science Department called USE, User System Ergonomics. Anyway, this is what I want to talk about today is what I've been doing actually for about almost 9 years at the Media Lab. We have been thinking about how to use sensors and what I call virtual sensors to understand and respect human intention. And what's a virtual sensor? It's something that's allowing us not to have a sensor. So AI has been a topic that people wonder, is this thing going to be valuable? Is this not going to be? And I found that by having models, dynamic models of user, task, and system, I've been able to make many scenarios much more productive in natural, even dangerous, and difficult settings. Just to give you an idea of the kind of the breadth of it, the goal was to really show that this stuff works everywhere. So we have a system. Do I have a pointer? I don't. Okay, there. This is a website called the Living Center. It's on pbs.org, and it's a place where people can interact with their loved ones when they have Alzheimer's. And by having a smart model, when you're playing puzzle, if you are doing well, the puzzle gets harder. If you're not doing well, it gets easier, all the way to it's doing it for you. And by kind of replacing the a lot of the need for having memory, we make a system that is actually brings people together, reduces the stress of the relationship, and it's kind of fun. So we have this, a lot of people realize that people with Alzheimer's are forgetting things. Well, they're still very critically sophisticated, even if they are not able to create things on their own. And so if we have a memory prosthetic, we bring them into their own. Let's just move on, and I'll let's see. I go down. The idea is that intention might be able to be recognized and respected, and I like the idea of maximum amount of implicit communication. That is, just getting the information from the stream of things that a person's doing. I want people to be focusing on their task, not on the tool. This is an image from a gallery use of our floor in New York City. And this floor, it was all over my lab. I've taken it up in the last few years. And basically 10 cents a square foot, we made a sensor network that if you were a bunch of people sitting in one place and there was one person over there, it put the spotlight on that person and put a podium on the floor for him to give his talk. If there was a couple people here and a couple people there, it puts little footprints between the two, tries to focus people's attention on the fact that you are standing together by making little butterflies on the floor. It does all sorts of things to enhance kind of the concept of a social commentary. But anyway, it also gives demos of the lab, and guess what? When there's a lot of people in the lab, it doesn't give demos of the lab because whoever's in the lab isn't going to like the audio of another person being shown, hey, this is the kitchen over here, and so on. But the basic idea is, can computers read our minds? And so one of the first IUI papers we wrote out of my work, actually this work I did when I was on sabbatical at MIT from IBM, is to make a door. A door is a social demarcation. It's kind of maybe one of the most important social demarcations. Do you belong in that room or not, that house, that whatever? And so just by having an organizational model, that is, if Nicholas Negroponte came to the door, he got let in no matter what. He built the building. Whereas if my wife came to the door, she could see my whole schedule. And when Win Burleson, who came from the design loft here, by the way, years ago, was at my door, he only saw the schedule that worked for students, excuse me, when he was scheduling appointments. Now, on the other hand, if Win comes to my door and I'm in my room and there's nothing going on, it will alert me and I can say, please come, I'll say yeah, and then it'll say, please come in. If I'm in the room with another person, it might say, Ted's busy, do you still want to bother him? And if you say yes, then it alerts me, and if you say no, it puts up a schedule. So it's got a model of user, what is his role with respect to me? Task, it's really the receptionist. And the system, what can it do? What is its role in the world? And that very simple thing, it was a fantastic system. It's just a rule system. We tried all sorts of, we used phones, we used speech. Voice was a really nice one for this particular application. I often don't like voice reco because, well, anyone can recognize speech. So we've done lots of different kinds of sensor approaches to discovering what a person's doing. And, this mouse tracking thing is one of the things we started very early on and have gone a long ways, which I'll talk more about. But Andrea's here looking at this dog, and that dog is barking at her because she's wearing these glasses and it can tell it's being stared at. And these glasses were first designed to be used in a party, and they would give whoever was being stared at the business cards of everyone that was staring at them. And when you looked at a demo, it would send email to you if you were interested in the demo. And I'm going to talk a little bit about some of the stuff we've done with eyes. So we started off thinking about the fact that when you're looking at somebody, it's not to gather information. We paint a very nice big picture in our minds. You can access everything you've looked at for a half second in iconic memory. You look at things to make social statements. And so we made various examples of using gestures, eye gestures, to control things. So this is me in bed at Good Morning America. And what I've done is I've made a little gesture language where I can look. When I wake up in the morning, I open my eyes, it turns off the alarm, puts a nice beautiful landscape on the ceiling. I look up on top of the hill where there's a TV, and I stare at it and wink, and it turns on the TV. If I blink nervously, it changes the channel. And remembers what kind of programming it had and what kind of channel it is. We have this little taxonomy of kinds of programming that we used for the radio and for the television that were extremely good at making programming that people literally would leave on for weeks in their dorms, by the way. Just a little criticism, and it kept getting better. So, wink, blink, stare, gaze, very, very simple thing to just notice a person isn't really interested by their eyes are kind of wandering around or not fixating. And it was a very effective thing. We've done a lot of examples of using those kinds of things. What's impressive is that these same gestures can be recognized with one photodiode. Okay? This has a $1 processor and one photodiode, and it can tell that I am staring at you. How does it know that? Well, it can tell if the eyes are open and closed. It can tell blinking. It can tell winking by time. It can tell moving around because it's looking at how bright the reflection is, and it can see the dark part of your eyes moving around because it's changing in ways that look like that, as opposed to just getting no reflection at all when your eyes are closed. And so without any camera, we were able to get all those eye gestures. And then to find out where you're looking, we use a standard, remote control IR device, and we're able to, it's about 18 degrees, and guess what people do? Within about 18 degrees, they don't really move their head, and then they do. And so it's kind of like, if you put two laptops next to each other, and we did, you'd have one movie over here and one over there. I could tell which movie you liked just because you'd be moving back and forth, and I'd get this thing looking at different things. So it's the semantics we care about always, but it's just interesting that if you think a lot about sensors, you can do something with very, very simple sensors often. This all started with a bunch of experiments where we kind of started realizing that when people are looking at things, they're looking at things differently. And as early as the 60s, this Yarbus did this great work where you can really very easily tell what questions were asked a person by how their eyes fixate on this coming home to dinner picture. And so our very first work in this area was just saying, all right, when a person stares, can I use that as a way of deciding that they're interested in something? That actually, in something called SUITR, Simple User Interest Tracker, came across the screen one day. What was this kind of thing at the bottom of the screen? What it was kind of a filter of news and of some help from the systems that were open on the screen and a bunch of other stuff. And then if you glanced at it and read it, no big deal. But if you stared at it, and I'm saying a third of a second, we could tell you were staring at it. So we were literally able to make decisions about, you want to see this article in half the time that it takes to make a selection with a mouse. Maximum time in a mouse is 0.9 seconds. That's kind of what people can do with a mouse. And so that was kind of exciting. And then we kind of took that stuff from Yarbus and made something called Envision, where we could tell where on the screen you were looking. Maybe as a way of grouping things, we could tell when you're moving between things and kind of connect them, not think about where you're fixating as much as where you came from and went to. And by looking at where you came from and went to, and expected your eye always is moving around because your eye is a guard dog. It's not just looking at one thing. We could group a bunch of the sponsors that were MIT sponsors of the Media Lab for the ones that you liked, and that worked really well. But the most surprising thing that came from it is we got a much more accurate eye position reading by saying your eye is coming from somewhere and going to somewhere. We have those two vectors crossing as opposed to sitting there, hey, hold your eye steady. I don't know, you guys have all seen those demos where you hold your eye steady, we have to, you're not doing a good enough job yet. Well, nobody likes this. Nobody likes taking their attention away from people, really, and being told that they can't look at things. Their eyes are owned by some computer. We've used lots of different sensors. Here's an example that I really love called LaughCam. We took the microphone on a normal camcorder, and we pointed it at the person that was taking the movies. And what do you get? Well, you get, here's something you can point with. You get various things. You get these laughter things. Andrea Lockhart likes to giggle a little bit, and she giggles specific times. One time was when somebody was videotaping her, videotaping them. One time was when there was a really great band in Harvard Square. and another time was just something she was interested in. And you know, people have always talked about how great galvanic skin response is going to be and all these biometrics. I want to say that we spend a lot of our life learning, you know, handwriting and seeing and interacting and communicating with the things that we use to communicate. These bulk biological things are much more clumsy, and so you see that maybe the sun went behind the clouds. I'm not sure, but here's our galvanic skin response. It really is a very, very messy thing. So we put that on there. It's nice to put on the strap, you know, nice ergonomic thing. You got the camcorder with the microphone already built in and the strap already built in. You can get those implicit metrics and do things with it. Automatic editing of video seems kind of important to me. All right, so we've also done things online. Here's a paper from IUI that Hugo Leo did, where we just used what they're typing. Bag of sentences approach for evaluating what you're writing. There's this thing called open mind. Probably everybody's aware of open mind. The way I look at it is, if you're going to ask, you know, if you have 1 million sentences that people have written and you look for the word fear, you're going to have lots of examples of fear, anger, surprise, and so on. And those kinds of things are pretty accurate. And so when this thing starts making a surprised face when I say I went skydiving last Saturday outside New York, you know, you can kind of believe that we were able to do that. We were very good at doing those kind of things. And what's interesting is when we had just some text up here that said surprised, no one did anything. When we thought of putting up a face that described how what kind of emotion there was, people changed stopped flaming. Really huge improvement to people's use of this thing, or actually even their ability to use it. And I think that what's really often missing in the development of technology is that people think they've made something useful when they've made a technique. And technology is figuring out how to use some technique in a way that's going to be robust and reliable. It's not technology until you know what it's going to do. And so we think that we're going to make, you know, speech record technology is going to be useful when it's 99% accurate. Well, hopefully that 99% is in the domains and in the scenarios that we're really going to need it in. And actually, you know, speech recognition is a lot about feedback and so on. So I really believe deeply that the interface and only asking things what they can do is the crucial aspect of turning any technique, no matter how fancy you think it is, into something that's useful. And I could tell you 100 stories about that. Anyway, meanwhile, back at the ranch, another thing where we were looking through emails is Andrea Lockhart's master's thesis. She's now at Georgia Tech. She just took a job as a professor there, by the way. Wonderful person. And what we did is we threw some parties. It's the Media Lab. You throw a party. The party's entrance fee is you got to email a bunch of people you don't know. And we want you can keep coming back to these parties as long as you're making friends and you know, exhibiting social behavior. We took the corpus of emails and we tried to understand what characterizes when you're going to respond to an email or when it's urgent and things like that. Well, you know, it's hard when you're doing a master's thesis to get enough data. We've all seen that problem. So her results are 65 to 75% correct for you know, a few different characteristics. Pretty bad. So we go and run a study and we make these really weird user interfaces. I call it the ransom note interface. So you could imagine that this is taking the same amount of space on the screen as a normal. In fact, it looks just like a normal email system the other group had, only it's got these weird, you know, font changes and color changes and these bars over here. And so we told them, hey, you're Ted's secretary, and you got to make him you got to schedule his time, and he has some family things, and he has some, you know, whatever. By the way, we picked the party thing because we wanted to get a corpus of social exchanges. A lot of business corpuses of good business email that I found it'd be interesting to work on the social only if we could. But anyway, significant difference. They both groups answered the same number of emails. They'd been given criteria of what was important about email, the emails that they were going to respond to. And even though these things are, you know, 25% of the time, minimum, the coloring or the change in font or this bar is not actually what it should be, people were significantly better at responding to the correct emails. Very exciting to me to think that we can make things that work inside of ambiguous data, and people liked it better too. That we can make things where it isn't frustrating and brittle when it, in fact, isn't perfect. So that's kind of a exciting thing. Of course, you don't want to make mistakes when you're driving. Chrysler worked with me and my group to make the Chrysler 300M IT edition. And the IT edition had hundreds of sensors in it. In the end, I threw them all out and just focused on what was on the CAN2 bus. That's the bus that's already in the car. And I did almost hurt myself by putting I'm always working on things, putting a sensor on the steering, which luckily now if you get a car, it'll have a steering sensor, but it didn't then. All I had in this was a criticism and an affirmation knob. So you could turn up the criticisms or the affirmations. And what we found was really interesting. Just by taking blinking, brakes, gas, speed, steering into account, we could tell if you're drunk or if you're falling asleep. We could tell if you hadn't put on your signal correctly. We could tell if you were doing jackrabbit starts and really heavy braking. And what we found was, I think it's the only slide on this, so I'll just, what we found was that basically if we mostly didn't say anything and gave more affirmations than criticisms, we got people to improve. So scheduled reinforcement, variable schedule of reinforcement, improved people's driving significantly. Giving them all the information that we knew about them definitely did not help them. And so that's kind of exciting. This is this whole point of how do you decide when to respond? Why is it important to be thinking hard about the feedback loop? I think that most UI people can't even apprehend this idea that their UI might be inappropriate. And I think this whole business of what's appropriate is the beachhead that I care about. So you'll see a little bit more of that as we go on. But anyway, I'm very proud of this. Very excited to think that you guys can throw your $3,000 worth of cameras on the front of this car, and you can use radar and everything. And guess what? I can just interact with a person who I believe is a good driver, but just isn't driving as well as he should right now, and I can make him drive better. This is, I don't know why it's right here, but anyway, this is a very recent piece of work. We have been making for some years attention interfaces. And there's this tool that we've been giving out. You can get it on the web for recognizing how attentive people are being. And we put on workshops in Taiwan teaching people to use head gestures as input for their user interface. Is really fun working with architecture students and getting them to use it in new modality and stuff. And what we found is that it was very difficult to get people without one-on-one teaching to know when to use what interfaces, affordances in a new modality. So we found in the study that if we made the interface that shows you, what nodding and shaking and eye close did in a way where it reflects back to you what it thinks you're doing with your face relative to what it can recognize, people would actually attach the affordances better to their interface. In this case, we have an interface where you can set up, and I think you can download this and use it, set up your desktop so that you can just use nodding to go back in your web browsing, or use shaking to go forward, or whatever you want to do, so that it literally just pretend it's a keyboard in your Windows interface in this case. Lot of work on controlling disruption in my group. I'm a very interruptible guy, and a guy named Ernesto Arroyo just got his PhD this summer. Or was it this fall? It's hard to finish theses on Disruption Manager. And one of the first things he did was this little baseball window that gets bigger when the crowd goes wild or when you stop doing a lot of stuff on your desktop. So it's kind of trying to decide, should I be paying more attention. This is just a picture. We've done so many different things with mouse tracking. And one of the first things we found was that it was very easy on a web page to tell if somebody was a business traveler or a vacation traveler on a travel site just by how they moved their mouse, if we put up certain kinds of things carefully. And of course, a lot of marketing people, our sponsors loved it. But we've also found that we can teach people, this was actually from a workshop on teaching people to do UI. It's amazing how, with a good tool like this, everyone can be Jacob Nielsen. It's just really obvious that for some reason, people aren't getting, over here, this space in this web, in this, this page is not very used, and so on. And one of our first things in this whole disruption area was we made a very bottom-up thing called Interruption Manager, and it worked, by the way, on all operating systems. There's this guy McFarlane, and he says, hey, when there's an interruption coming in, you can immediately do something about it. It can be mediated, it can be scheduled, or it can be negotiated. So we made an interface where you could, anything that pops up, any process that starts that affects your UI, you could have it do something to delay it or to mediate it or and not let it happen during a task and things like that. And that was fun, but we went a lot further and did a lot of experiments with how do people respond to IMs. And it's interesting, when people get an IM, a novice will deal with it instantly. Somebody that has a lot of experience with IMs will have their own strategy. And there's kind of three strategies we've discovered. Either they will deal with it at the beginning of their, I don't know if this is the way they'll either deal with it at the beginning and then never deal with it until the end, or they'll wait till they get their task going and then deal with the IM, strange idea to me, or they'll just wait till the end. Anyway, that's kind of interesting. What we kind of have done is started making a whole model of all of the different things that affect whether you're going to be ready to be interrupted and take the interruption on and become disrupted. That means you stopped what you were doing. And what we find is that the big breakthrough comes when you start noticing what all the emails are that the person's gotten in recent time, and you kind of notice what they've got open on their page, and what they've responded to recently, and whether they're typing, and whether the mouse is moving. So you can take into account a bunch of bottom-up things, a bunch of top-down things, and we had an effect of, this is the minimum number we had improvement in performance. Here is our experiment. Okay, it was a mess. You are taking orders over email, you're doing calculations up there to price out stuff, you're going on the web to look up these things that you're going to deliver to a customer, you're getting IMs from other people, from friends, and also from your boss and also your colleagues saying, hey, we're out of stock on that, or we're changing the price on that. 25% increase in performance with Disruption Manager. We tried a couple of different cases, and it's interesting. People actually listen. You tell them, hey, it matters to go fast. Don't worry about accuracy in your task. 30% improvement in speed. But if we ask people, be very careful. It's important not to have any errors in your orders. 25% improvement in reducing errors. So basically, all we did is delayed the IMs that weren't relevant for up to 2 minutes, and that was the only tool that we allowed ourselves, and we got this incredible success. And I just think it's very, very exciting. Another one of my students has just deployed this recycled research, and you guys are welcome to try it out. That's Matt Hockenberry, and what he's done is, at Google they have all the data, what everybody does. Well, he made a system where if you use this thing to make, some websites and people go to that website, we're going to know how they track their mouse around and how often they went to different parts of it, and just a place where we can have an open repository of the kind of UI data that'd be useful for people to use in understanding how to do experiments to understand web usage and using the web as a tool, as a research tool for usability things. So I encourage you guys to go find out about recycled research. In the counterintelligence project, which Wendy Ju was a big part of at the very beginning, we've done lots of stuff. And one of the most interesting things that happened when I first got involved with it is I met this woman named Barbara Wheaton. She was about 70. She's still with us, by the way. And she built the culinary collection at Harvard in the Schlesinger Library. And she had this mind that was just amazing. She just knew everything about all writing on food. And in 1960, she started putting it on cards. And then she moved it over to FoxPro, and then she moved it over to Microsoft, or whatever it is, Access, I guess, or Approach, or whatever they do over there. Anyway, and so I thought, my God, here is a common sense repository, right? It's a domain with a small number of keywords. It's a domain that includes culture and describes culture. It's a domain with a very few number of keywords. There's only 1,000 kinds of different ingredients, period, in all of Western cooking, okay? And so I said, we're going to be able to kick ass. We're going to be able to do common sense reasoning on this. Marvin's my friend. We're starting to do common sense reasoning around here. So after my third try, I gave up, okay? What did I find? I found out everything we learned in psych. I found out that, not only was her language inconsistent, but her terminology was inconsistent. And it didn't mean that she couldn't get what she needed from her database either, by the way. She was very effective at using it. It's just a real mismatch in the way that people will categorize things and the sloppiness that we put up with compared to what, any reasoning thing will. So we kind of said, Barbara, we love you, and went and scraped the web. 9 million different hits on food recipes, took these recipes, and kind of within 6 weeks we had an amazing thing. We could tell the difference between ingredients and flavorings using this common sense reasoning idea that's called open mind, which is that basically you have a bag of sentences and you look for generic things. So in synthetic recipes, we got to the point where you start saying, hey, I want a aromatic, chewy, not spicy, and it starts classifying recipes among those things. You can say, I want a romantic, Italian, dinner, right? And what is romantic in terms of food? Well, it looks up. It has a bunch of ways that it can tell what to do with the word romantic. That worked out very nicely for us, and just love this system. I only showed it at SIGGRAPH as a paper, but and there's the ubiquitous pointing device. I just want to say a little word. I invented this pointing device there, and the thing that was fun about it is that it taught me the whole thing that I've been doing ever since, which is there's a cognitive model in the microprocessor that recognizes how shaky your finger is, how fast your eyes move, how people like to start and stop movements. And all of that was stuff that came from some intuitions that were wrong and some experiments that turned those things on their head. So the experiments were always the things that taught us able to do it. And we really got a 25% performance improvement with this compared to anybody's joysticks in the past. In fact, for typing and selecting, this thing is 20% faster than a mouse. So if you're really going to be text editing and moving around, it's going to be faster than a mouse. And so it's a great thing. But the most important thing that I learned from it was the scenario matters. And that's what I keep talking about. And there it is, trying to teach us that's true. This was a slide that got it into product by kind of putting a bunch of different experiments from people in different laboratories all over the world together. But it's kind of just amazing that, immediately the trackball and the trackpad and, by the way, are about the same, and then very quickly they differentiate. And getting it into product, by the way, not that I want to dwell on this, was all about these usability experiments because this thing didn't make sense intuitively to people. And also, a lot of things to learn. I mean, one of them was that even though it was a great thing, it was not as good as the trackball for the first 30 seconds to 45 seconds when I was showing it to the product people. And they said, well, we can't put it in then. I said, why not? Well, that's when people make up their minds by trying it for a few minutes, just seconds. And so we had to fix that too. And so that was by the way, the fix for that was was making the top have a proprioceptive feedback. And who would have thunk it would have helped that much? But for novices, feeling some motion made a huge difference to their performance. 15% was all we needed, and that's what we got. So that's just an example of that stuff. And you can make big mistakes, and one of them was to work in an area that somebody else is working in. So we made a scrolling device. How many people have ever seen a scrolling device on an IBM thing that you really? Well, what's fun about it is it's 30% faster than a ball, than the wheel. However, and we published a paper in Chi that showed that it's this is one-dimensional, that's two-dimensional. This you're walking along, and that you push the joystick and goes, so people call it, Buxton will say this is a RSI enhancing feature. On the other hand, Microsoft decided to take the Xscroll and vScroll APIs out of their Windows after we introduced this. And so that means you have to load a driver for us to get down underneath and reverse engineer stuff. And you'll find out that the scrolling is a little weird. Well, it's not our fault. But anyway, don't make enemies. Okay, so autonomous things can have context too. And a simple place to do that for us was just showing that one sensor could do something. So we put one sensor in the refrigerator on a leftovers thing, and what's it do? It just says how many days is this thing being cold. So if it's chicken and it's been 4 or 5 days, you start worrying. The talking trivet is almost as simple. You put it on a burner and it says fire. You put it in the oven and you touch it to a pan of bread, and it says if it's above 212 and below 400 degrees, ready to take out. If you take a pizza and put it into the oven, there's a sensor on the back of your hand and one on the front. If the oven's 450 degrees and the pan is cold, it says, I'll remind you to take that out in 15 minutes. Now, this is a model of cooking that it's using. It could say a lot of things, but what it's trying to get you to realize is if it's a pot roast, 15 minutes doesn't make any sense. And you're going to recognize that 15 minutes confusion much faster than you're going to recognize that's the wrong temperature for a pot roast or something else like that. So I really want to make the person think the right thought. That's what the feedback loop's about, is getting them to understand what they are doing that would be, that would be central to whether they're going to succeed. And if you put a pot on it, who'd put a cold pot on a hot pad? It says needs warming up. So it's just a simple thing, but it's got a model of what its value can be as a hot pad, and that's what it uses to drive all of its stuff. Another autonomous example early on was this dice. I invented a funny little 3D sensor for it, but the dice, what it did is if you're a baby, it just kind of tries to get you to play with notice the different patterns, and then it tries to get you to find ones that have a dot in the center or are all diagonal. And then it tries to show you what a number is, and what counting is, and what arithmetic is, and what probability is. And this point that an adaptive user model can interact with what you're doing to make something so sophisticated that a 7-year-old or a 9-year-old might have trouble with the probability issue is fun to me. It becomes fun when we take a very simple sensor and a very simple scenario and show that it can do something much richer, like the talking trivet or this, or we can take a very complicated scenario like driving and make it very simple by just recognizing a few very relevant things. In the kitchen, we kind of got excited about doing things. We did lots of things. This is the soft sink. It's coming up to meet Leonardo. It had a camera, has a camera. You can put your hands under it and it'll make warm water, turn the water purple. You can put vegetables under it, it'll turn it blue, turn the water cold. You put a pot under it, it turns it hot, turns the water red. You know, they run 185-degree water in commercial kitchens. That will give you burns. So it's kind of not just a toy. When you come up to this thing with a pot of water, it lowers itself. You put and then brings itself up to an ergonomic height so you don't have to pick the bucket up over the edge. We made for Kaiser a demo where when the doctor comes into the to the examination room, the electronic door jamb sets, and after he's washed his hands for 15-20 seconds, then it lets it close again. What they wanted was, and we made it for them, an RFID thing where when he comes in it registers whether he's washed his hands or not. I want to say two things about that. First of all, doctors won't put up with that kind of stuff, and guess what? None of us want to be disrespected. But the other thing that's interesting, you know, in the permanent record, we all love the permanent record, I'm sure, is what you didn't realize is 50% of people in hospitals that are supposed to wash their hands don't. They literally pay people to watch people wash hands at Kaiser because they have to, because they can't afford to be having people operate without it. Anyway, we did lots of things. Another thing we did in the kitchen was this smart spoon. This one is the good-looking one. We never show it because people don't like to see the one with the wires in it like that. And it measures pH, and it measures temperature, and it measures salt. And there's a lot you can do. You can tell if, I made some, there's me on Good Morning America again, making some crepes. I got to do it on Martha Stewart too. It can tell whether there's enough baking powder, enough salt, and maybe 13% of householders now cook. Maybe we can teach them how to cook. Now, I rode my bike to work every day at MIT. It's 6 miles, it's 25 minutes, driving's 45 minutes. Everyone should ride their bikes all the time. However, there's a couple of different issues. The first one that I kind of ran into was one day I fell off my bike. And I was getting up, fallen off my bike because somebody had come out of a very small parking lot right between two cars that were parallel parked. And somebody coming down the apartment steps, oh, that's the third time this week. And I thought, hold on a minute. Why is this a dangerous place and everyone knows it and nothing's happened? No signage. Well, it's not a public parking place, whatever. So this helmet, when you shake your head, it will record what happened. And then when you come close to that area again, the GPS will go and get that recording and play it back to you. So now we're making virtual maps. So you can say, hey, there's a great soda over here, it's a good park over there. Oh man, there's this awful intersection right here, whatever it is. Maybe we could share it. I didn't get that far. I didn't share it with other people. It's only my map. When you make your head go to the right, makes the blinker on the right go on, makes it go on the left. When you take the helmet off, the running lights turn off. It has a little accelerometer that's, if you scream, it covers up the scream with a horn. If you talk, it gets the Bluetooth to your cell phone. You can talk. Maybe some of you have talked to me on the phone while I'm riding my bike. I do it all the time. I found out that some people don't like it. Some people do. And if you don't do anything, it's playing the MP3 player, unless there's a loud noise outside. If there's loud noise outside, it turns that off and amplifies it. All sorts of things that you can do. All of them, I want to say, came to me because in the mid and late 90s, I was making the fastest wearable computers on the planet at IBM. We couldn't sell them, and I realized that maybe the whole scenario is wrong. What about augmenting things people have to use anyway? This thing is less than 4 ounces with battery, okay? And it still lets you have it. Did you ever hear me taking my eyes off the road in that story? Never. Did you ever hear me taking my hands off the handlebars? Never, okay? These are, a lot of the things we make, we say, oh, they're just so great. That's how we start telling a scenario story. If, and the next thing they say, I cover up my eyes so I can't see, and I take my hands so I can't use them. And that's what augmented reality's been. Where does it want to go? This is a nice place. This is a nice place where we get to do what we're trying to do and more. So there I am in Bicycling Magazine. That's fun. Here's another autonomous one that's kind of interesting. So Philip Morris, God bless them, was a member of the sponsor of the Media Lab. And they came and said, well, what should you do in the future? And I said, well, cigarettes are getting illegal. So what about the digital cigarette? I mean, certainly we still want to meet babes. We still want to define ourselves inside and outside of social circumstance. We still want to take a break. We still want to motivate ourselves to keep writing that great American novel. There's all sorts of these social motivational and social getting together things that cigarettes are about that I put into this cigarette. And we played with it a little bit. Certainly the PhD student decided to change his thesis halfway through this because it's pretty bizarre. But I don't think it is bizarre in that I think that everything that we do in the future is the cigarette. Everything that we own is our way of showing who we are in the world, sharing, breaking social barriers. And so that is the direction that I believe is important to go, is to figure out how we're going to make all of the things, all the systems we interact with, be part of that, be the cigarette of the future. Here's a cell phone that we made for Stop and Shop that lets you play with your kids and play with the food and bring home more groceries. And we've done other things with cell phones. This is a nice, simple one that we just finished up. Anthony just got his master's this summer. And what we did is said, you bring that laptop or whatever into a meeting room. Does that technology help the meeting? And we all know the answer. It helps you do your email. So we just made this simple thing, and it had all sorts of functions, right? You could just commit. And what commit did is when you push that button, basically it records the last 5 seconds of what you've been saying in the next 5 seconds. Okay? So if you said something important, you push the button. Or if you believe something's important, you push the button. And if everyone believes something's important, they all push the button. It's voting. Okay? And then what it does is it makes the web page that shows when people did push these various buttons. That one down there comes from, you can take a picture, you can type something to the other people in the meeting, you can do all these other things. We turned all those off for our experiment. And I believe that probably all of them make it worse. All we had was the commit. And we took a bunch of people, gave them all different resumes. They all thought they were looking at the same resume. Of course, little discrepancies in them because we wanted people to have a controversy. And they could write in paper, or they could push the commit button. And so we had 2 groups, and the group that only had paper just couldn't remember how they'd made decisions as a group as well. Both groups came up with conclusions in about the same amount of time. So very excited about this because it's such a simple interface. And memory of what really happened in a meeting is vague and tenuous and kind of gone after 2 weeks normally anyway. So kind of excited about that. I've told you a little bit about this augmented lab that teaches you about itself. And there's the 10 cent per square foot sensors. I always build sensors. I don't know why. And here's our smart kitchen. Sure enough, we had some common sense in here too. This is a pretty early image. I'll just say a couple words about it. When there's a picture on the refrigerator of what's inside it. If the picture says at the bottom of it, contents, people don't like it. If, when you walk over to the refrigerator, it kind of comes up slowly and fills the whole refrigerator the way it does there, people don't open the refrigerators often. If you have the freezer make a wind sound, it looks like snowing, they'll close it so much faster than if you say something like, be energy conscious or some awful thing like that. These are things we didn't know at the beginning. You see, the reason I say it's an early one is see these words all over the place? Those words suck. People hate seeing words painted for them to read. But hopefully the picture will. You're not going to see. You're going to see some video. But when you put flames behind the, is he going to do something? Yeah, he's busy using virtual buttons and doing stuff in the common sense systems, deciding what kind of information to give him and where to direct him to go. But when we put flames on the wall behind the stove when it was on, people turn it off more often. When we said hot, people were just annoyed and were distracted actually by it. Same thing with the sink. When we put little waves behind it, people would turn it off quicker and enjoyed it. When we put words, faucet on, people hated it. So I think there's a lot of very subtle things in these scenarios that we have to be conscious of when we're designing things, and we have to learn to do experiments about. This is when I got to brag. 30th year anniversary reissue of People magazine. Jessica Hahn was on the front cover, but I got the open 2-page spread. Of course, because it's MIT, it's not a person, so it's already being tested at MIT. But here it is, and there's a couple other things in here. When there's not much people going on in the room, it puts grass on the floor, it puts marble on the floor when there's a bunch of people in the room. When there's something wet that happens on the floor, it can signal that. And a lot of other things that we did in the kitchen. The attentional vending machine uses our attention meter that I was talking about earlier. Pepsi's considering doing something with it, we'll see. But it's been a lot of fun. What this thing does is it's got 14 displays. And when you're, these are old versions, but when you walk up to it, it kind of greets you. It's really interesting. If you have an attractive image on a vending machine, people will just stay there and look at it. So we put, when you put a map on the front of a vending machine, people just hang around there. In fact, somebody came up to this one where they had a map on it, and decided to buy some soda. 3 people that were looking at the map went off to buy the soda also. Now you don't know whether they were waiting for somebody else, didn't want to intrude on the space of the person watching the map, or whether this person gave them the idea. But in any case, there's a lot of problems in the way that these machines present themselves and what they think their role is in society. It's so bad that vending machines are put under the stairways in the back near the bathroom at airports, right? What is it that makes these things so annoying? Well, they're just saying Pepsi. They're not saying I'm going to help the community in any way. And as soon as it starts saying, well, maybe the departing flights, and it doesn't say Pepsi, you're probably going to buy some soda there. It's probably going to be in a front and center place. So that's kind of some of the things that we've been doing with the Pepsi machine. This is the week to go buy yourself a $100 laptop. I could have brought one. I'm sorry I didn't. I had a lot to do with it over the years. These are some studies. I'm always building things. See, that's why my hands are uncleanable right now. Anyway, this is kind of a fun one that folds up to be 6 by 9, the size of the display, and has a full-size keyboard and, of course, a good pointing device in it. And no hinges, but we didn't get to that one. Anyway, this is a week where for $400 you can buy a $100 laptop, and somebody else will get one too. So go do it. And anybody that wants to, we can talk about $100 laptop a bunch later. I am the current, and since 2003, director of the Voting Technology Project, the Caltech MIT Voting Technology Project as a director at Caltech and at MIT. And we've done lots and lots of things. I guess I will just mention a couple. This is, let's just go. I'll just say a word about this interface here. This interface where you have all of the races shown, and there's a fisheye, here's the fisheye view of one, simultaneously, and you make a big damn deal out of when the person votes for something. People make half as many errors. How many errors do you think people make of the adjacency sort? That means that they think they voted for one person and they voted for the guy next to them. Just percentage. You know, how often do you think it happens? Do you think it happens at all?
2-3%.
You're very good. It's gigantic. 1 out of 30. You're right on. I'm just shocked. 1 out of 30. It's huge. Now, that 1 out of 30 number, that comes from my experiments. In real data, in punch cards is the only place we have data, 0.5% is what we were able to be sure came from that relative. I can tell you all about it. Sarah Sled wrote this paper. But I think it's really 2-3%. I think it's a gigantic number, and it seems to be persistent across all technologies. In my experiments, that's what we see, 2-3%. Terrifying. Big UI problem that nobody knows about. There's, the paper trails. I know you guys are all excited about having something to verify your answer in voting, and so I went and watched how that works out in real life. This is the third polling place I went to where they weren't trying it out, where it had been mandated and they were going to deploy it all statewide. This woman here has just cut this paper trail from this open ballot box that she opened on the day of election and breached the security, and she has no one standing by her to help her as she takes this paper trail and decides what to do with it. I don't know if it's going to go into an envelope, it's going to be taped inside the polling thing, she's going to send it back to her election official or put it in her pocket. But anyway, it's terrifying to me. We've been exploring the idea of, while you're voting, hearing how you voted through the audio and having an analog tape recorder record it. And so we've done experiments comparing these two, in fact, some other kinds of verification methods too. And it's kind of interesting from a user interface point of view. We had 106 ballots. We're getting late. I'm sorry. Each of which had 2 errors on it. And the error could have been a missing race or incorrect marking on the paper. And so basically, with the paper trail, we find that this is just how people felt about it. They thought that there was an error. We had 7% of the people with the paper trail, 85% with the audio. I don't think I have that data right there. I'll just say it. In terms of how many people actually reported an error, 0 of the people with the paper trail reported an error. Only 14% of the people with the audio reported it. So it's really scary how bad people are at noticing their errors afterwards. But the idea of the audio was to instead of it being a memory task, that is, you vote and then you read your paper trail, make it a perceptual task. Separate modality, not conflicting. You do something, you hear something weird, Bush just doesn't sound like Gore. And that's kind of a, perceptual advantage. Anyway, there's still work to be done, but probably it'll be illegal to use the audio quite soon. So Sarasota, anybody remember what happened in Sarasota in 2006? 13% of people didn't vote for the second race in the ballot. And it was a very strange race for people not to vote for. It was Katherine Harris leaving office. Katherine Harris is the person that stopped the recount in 2000, so it was very strange that people missed this, and people claimed fraud. I have literally done 5 experiments to try to understand what the heck happened, and nothing published yet, I'm sorry, but we have some very exciting data. Before I tell you what that data is, I want to just show you what the pattern of voting was. If you take a look at whether people said, hey, I'm a Democrat or I'm a Republican, relative to their party loyaltiness, as measured by looking at the ballots and seeing if they voted straight party or not, we find a pattern for these various different races that they undervote more if they aren't very partisan. except for Sarasota, the congressional race. So that's kind of interesting that it was across all political positions. And that kind of is a clue that it's not a partisan thing. It's a user interface thing. In fact, even before the election, the election commissioner came online made a video presentation saying, "Be careful not to miss this race." What it was is that it was orphaned. So there was a big, at the top of the race, it said, do I have it on the next page? Yes. This is what it looked like. See, it says state in green, and right above that there is the race that we're talking about. So it's a small race at the and a big race near it. And what we find is this pattern of when there's a big race and a little race near it, at the top or at the bottom, you make mistakes. Now, if the race is at the bottom, we expect people to make more mistakes at the bottom, and they do. In a nearby county, Charlotte, they made 22% of people didn't vote on the third race on an election. That's a very large number. It should be about 1.2, 1.3% maximum. So we didn't hear about this one because it wasn't a close race. And so a lot of what you hear reported in the voting literature is about things that are, that people want to make a difference about. Just for example, the Chads, a big Chad problem in Florida, in Palm Beach County. 19,000 people voted for 2 presidents in 2000. Okay? It's a big number out of 300,000. How many Chads were there? How many hanging Chads that were being disputed in that county? That's the big one, by the way, Palm Beach County. It's the one where it happened. Just guess. Nobody's going to guess? 609. Okay, so the Chad problem was much smaller than the user interface problem, created by the butterfly ballot, which people forgot to realize. The reason we don't remember and haven't done enough about ballots is that it wasn't litigatable. The Chads were. So there's a lot of complicated things about how we decide what to do. And I just want to tell you guys, as we're finishing, that in my view, it's the testing that gets us the understanding. My views have changed radically and several times in my experiments with everything, including the voting issue. Here I am thinking about what the future field of tools should be. That is that you should feel free. There I am, standing on a little piece of ice at the bottom of Mount Everest, and I feel like I'm just free and naked and easy and everything's good. Well, I've got chromolybdenum and plastic and polyester, and I've got carbon fiber on my hands. I came over in a 747. Very much technology was involved, but the goal of it is not to feel that way. And here I'm very happy. I just got this blood oximeter to work on my chest, and they're going to use it to climb Mount Everest. But basically, I'm sorry to go through so many different examples. Here's like 48, I guess, different platforms we've made over the last 8-9 years. And I just wanted to say that the reason that I've been doing it this way is because people say that you can't use these kinds of technologies in complicated and dangerous situations, or that they aren't really ready for prime time. I think that it's about a different design approach. It's about a design approach that centers on scenario, feedback, and experiment. So thank you very much, and I'm open to questions. Sorry, I went over. I guess it's 1 hour. Yes.
So I wonder if you could talk a little more about the voting project. And I guess it's just a question asking for a little more on, I know that you've done a lot on this at MIT. What kinds of things are you envisioning for the future of voting?
Well, what would I like to envision? I would like to envision a world where people make decisions when they are looking at the semantics. It's a very strange thing, voting, where you walk into a booth and then you pick selections that are labeled. You aren't looking at the information that it's about. And even when you look at how we run elections today, something I was talking to Harlan Baker about just yesterday or something, we aren't thinking about the issues. We're thinking about the name associated with a big bucket of positions, right? And I dream of a world where decisions are made, on merit by people that are knowledgeable. So that's not in anybody's calendar. It's not, I don't think political scientists know what to do with those things, but I think it's starting to happen with a lot of the way that the web's used today, is that people are weighing in and getting more reliability out of data by coming to things that they care about. So that's a long range dream. In the near range, there's an awful lot of experiments to be done, and there's almost no one doing experiments. The shocking thing to me is the people that are involved in advocacy, and you know all of them because they're all over the newspapers, they are scared of research and have been unwilling, mostly, to actually evaluate the things that the positions that they're taking with experiments. So that's been a problem, and it's changing. And it's really going to turn into a field, but it'll take a few more years. In other words, a field is a place where people, where referees don't throw out papers because they're a position that's different than theirs. They throw them out because they're not well referenced and not well studied. And so that's not where we are yet. Yeah.
Where do most of your ideas come from? Do they come from the business community, the academic community, the government, combination, yourself?
Government controls everything. No, I'm sorry. I love to solve problems. I have a long-term interest in intelligent interface. I've been working on it since '78. That's kind of a tool that I use to hammer things, and it's broadened, in many times. I'm happy to work in any domain. I'm happy to have you shoot a problem at me right now. I love solving problems. I love thinking about. I'm an inventor, so that's what I thrive on, being challenged to solve a problem.
But do people come to you and say, "Here's a problem. You're the best person to try to figure out an answer for it"? Is that the way you? Because
that's a very uncommon thing. Most people don't want to hear anybody else's idea on anything that they have a question about. I mean, it's very difficult to get people interested in your ideas. So no, I see problems everywhere. Everything's a problem, and the question is, which ones are worth taking my attention to solve. It depends how bored I am with what I pick up. I mean, I pick up anything around me and start trying to fix it. But if people are serious and really want to solve a problem, I get excited. And if they are just, there's an awful lot of people that just, tell me another one. Tell me another one. That's really upsetting, actually, and it makes you not want to invent. And so possibility is what makes me have an idea. If there's really something that could change. I don't know if that's helpful. that's how it is, though. Yeah?
Could you give us an update on the one laptop per child?
One laptop per child, 500 megahertz, 256K of flash, meg of flash. That doesn't have a hard disk drive. It's got 12 hours of battery life if you're reading a book, 4 hours if you're doing computing. It has it's all open source software. It has is this what you're talking about? It has a operating system on it, Linux, with a user interface called Sugar, Homebrew. Oops, that's different. That's what I mean. And it's got loaded on it about 4 or 5 programming environments. You can do C-Sound. That's a nice digital signal processing language that Barry Vercoe did music. That's in there. It's got Squeak in there. You can do Smalltalk programming. It's got anything you want to do in Python or C++. It's kind of expects that, but it doesn't have compilers for those on it. And if you go to a wiki called laptop.org, you can get the simulator for it. You can get you can learn all about it. You can go and read all about it. You can go contribute. You can go and get excited enough about it that we'll send you one. If people are going to build stuff, if people are going to make things that are going to be useful to kids, going to be available for free, and they're going to really work with kids or really make a great tool, I can get you laptops, and they cost about $170 a piece in parts, but they're going to be given only to people that haven't paid for them, and they're going to go to Uruguay and Brazil. Now I better not talk. It changes all the time. But anyway, there's 4 or 5 countries that are going. We're going to make about 1 million of them in the next 6 weeks, and you know, the dream is 6 million in a year, and I might be wrong about the million, might be 500,000. They're green. They can take rain for 15 minutes. They can take hot weather for years. That was a hard one. You know, I didn't have as much influence as I wanted to, but I had a lot of influence on making it a little bit better here and there. And Nicholas Negroponte left the Media Lab to go build one laptop per child. Took with him the executive director, Walter Bender. The team's very small. It's in Cambridge. I don't know. I could talk all day about it. If you want, I'll come and show you one. Other questions? Yes?
The bike helmet design that you were talking about.
Yeah, let's make it.
How hard is it to actually build other than one you have?
Got circuit diagrams. I'd probably do it differently this time. And I could have brought it, but why didn't I bring it? I don't know. I didn't bring it. There's a lot, you know what? I've got, you know, like everything else, this isn't, at this point, it wants somebody that's serious, right? I mean, we can go make another cheesy one, but I'd rather make the real thing now. It'd be really nice to find somebody who wants to make a company and change the whole nature of bicycling and make it be a proud and honorable transportation method rather than just for the kids. But I think it's real. I mean, I think that, you know, it's interesting. It's demonstrating this idea of the value of a you know, wearable computer being something that doesn't distract from or disrupt a very complex thing, and yet, even as it is, I'm glad you want one. Let's make them. Yes?
You mentioned you've studied mouse trails extensively.
Yeah.
And you said you could distinguish between business users and consumers. And
Yeah.
So how far does that go? Can you identify individuals?
Well, we did one experiment that I found kind of fun with voters. You know, there's a huge problem with mail-in votes. I mean, people don't realize it, but it's where all of the fraud that's been litigated in this country, voter fraud, has been for the last, I don't know, couple decades. And it's going to be growing. You know, it's not a controllable situation. So I tried this thing. Okay, what if we were internet voting? Don't the arrows, stop throwing the arrows. And you're doing your voting. Can I tell if somebody's standing next to you with a gun? And the answer is yes. I'm very good at telling if you're agitated. Really have a different shape to your, didn't publish it yet, to your mouse trajectories. So.
What percentage reliability?
We've been getting in the 90%. It's not about detecting an individual, but it's looking for probability that you should go downtown and vote. You know, it's just another thing. Each time you add another way to know something, right? It's not just about, oh, is this good enough? Yeah, we got biometrics. Yeah, we got double passwords. Yeah, we got, you know, crypto, you know, everything. Yeah, we got inversion program. You know, there's lots of different cool things we can do. But then at the end, you know, it's nice to have other things that are looking over it. My view about voting, the big story is this. The only thing that's ever improved voting is when there's more than one person watching any specific part of the voting process, so that that's the way that you keep people from changing other people's votes. And that concept goes all the way to the software everywhere. You can use that. So anyway, but yes, a fascinating, incredible area. In fact, one way I like to put it is, eye tracking only looks what you're thinking about. Mouse tracking shows what you did. So, you know, people say lots of things. It's what they do that counts. So the mouse really shows your intention more than just your attention. So I think mouse is a very exciting area, beachhead really. Yeah. Any other questions? One more? 0? Pumped.
Thanks.
Yeah.
For information on other online Stanford seminars and courses, please visit study.stanford.edu.
The preceding program is copyrighted by Stanford University. Please visit us at stanford.edu.